Hello, I'm Mike Hogarth, Professor of Biology at Audubon University, and today I'm going to talk about the freshwater snails of Ohio. I have three objectives. One is to encourage interest in these fascinating animals. Two is to demonstrate just how important snails are to the aquatic ecosystem. And three, to introduce the field guide, Freshwater Snails of Ohio, by the Division of Wildlife. Here's a picture of the front page and then just a page within this booklet showing many of the aquatic snails that occur in the state of Ohio. Each entry of the aquatic snails of Ohio will have a photograph showing all three aspects of the shell for the most part, a map showing the distribution of that species of snail in the state, a little bit about its size, and then some technical information about that species of snail. At this point, I'd like to acknowledge the just outstanding work by my late friend and colleague Tom Waters, who provided most of the technical information for this field guide. There are four groups of mollusks in the state of Ohio. Freshwater mussels, 80 species of freshwater mussels. You can see some here. Clams, like this fingernail clam right here, and some introduced species. 20 families of land snails, 140 species of land snails, and 12 families and 50 species of aquatic snails, including the one you see here, the pointed Campyloma, and then up along here, some of the river snails, family of Pleuroceridea, that we also have in the state. There are two major groups of aquatic snails in Ohio. The first, the prosabranchs, have a gill, and this gill is in front of the heart. That's what the word prosabranch means. I'll tell a story about that a little bit later. These snails have an operculum, and so you can see that trapdoor-like structure right here. They use it to close off the aperture of the shell, and that is if this animal were to be disturbed, it would crawl inside of its shell, and then this would prevent most predators from coming after them. And you can see a little bit of it here in this river snail, and then in this mud snail. We have an operculum here and here. And these two snails right here are among the introduced species of snails. These are all native. And both of these groups, the prosabranchs here and then the pulmonates later, have non-native species, but these are perhaps the most destructive. And we'll talk about those a little later. And then the pulmonate snails. The pulmonate snails, instead of having a lung, or instead of having a gill, have developed a lung. And so these are the pouch snails, which we have here, the pond snails and the swamp snails, which are here, and then marsh snails. These are all pulmonate snails. These include the high-spired and then the flatly spired ram's horn snails. The way we would identify these different species of snails would be based on a number of the shell characteristics or characteristics of the operculum. And so these are some of the ways we might identify different species of snails. We might look to see if it has an operculum or not. If it does, then it's a prosabranch snail. If it doesn't, then it's a pulmonate snail. Or we might look at the operculum itself and see whether or not it's shaped like a cinnamon roll, like this one right here. These are only found in the Valencians. We'll get to those in a second. Or whether it's shaped like a cornucopia, or whether it's shaped like a bullseye. And so these are the three kinds of opercula that occur in prosabranch snails in Ohio. We could see whether or not the shell is right-handed or left-handed. What we do is we put the spire up, and then we place the aperture so that it's toward us. If it opens on the right side, then that shell is coiling to the right. If it opens on the left side, that shell is coiling to the left. In Ohio, we're only going to find sinestral shells within the pulmonates. And so this is one, and so are these, but they've done something a little bit odd. We'll talk about that a little bit later. Whether they're high-spired like these are, low-spired like this, or flatly spired like what we have in the ram's horns. whether they're smooth, finely etched, or sculptured. We can see some of the sculpturing here. The aperture size relative to shell size, shape, texture, thickness, all of those might be used to help us identify. If we're not getting anywhere else with it, we could really just try to get into the zone for identification, or channeling your inner mollusk might work. Um, I understand it might be easier to channel your inner fish, but dig a little bit deeper and you'll find that inner mollusk in there. The next few slides have pictures of all 51, or diagrams of all 51 species of aquatic snails that we find in Ohio. Most of these were taken from the North American Freshwater Snails book that was published by Birch in 1989. It first came out as a US EPA publication in 1982, and all these numbers refer to the pictures that are in that book. Um, these are the family names of the snails, and these plates that I put together are in the same order as you would find them in the field guide. And so if you do get inspired to go out and look for some of these snails, you might make some copies of these pages. These are only the ones that are found in Ohio, so you don't have to look through 750 different pictures. You can just look through the ones that you see here, or the pictures in the field guide. Let me just talk a little bit about each of these. I don't have time to talk about each and every one. Anyway, let's look over here at the Valencians. I've already looked at this one a little bit, and it's easy to distinguish from the others because of its three ridges that go around it, and so it's pretty well named, the three-ridge valvata. But look at the mossy valvata. It's much taller than the purple cap valvata. So anyway, so we could use these and actually be pretty confident that we have identified our species of Valvatiids correctly. I should also note that these pictures that I'm going to put up along the side, here's another one, are from the field guide. Mud M. Nicola, and I put this one up here because it is this family right here. It's the only member of this family that occurs in Ohio, although there's some debate about how many different species of M. Nicola occur in the state. Most recent data suggests that there's only the one, and then the hydrobiids, which are wrapped around it right here, 4 different species of hydrobiids that occur in the state, including the Midland slit snail, which looks almost identical to the mud M. Nicola, and they're about the same size. This is about 3 millimeters. The only real difference is if you look at the body whorl of these, this body whorl is much more broadly rounded in the mud M. Nicola than it is in the Midland slit snail. Another group of these prosoprank snails, the ones with an operculum, are the pleurocerid snails. And so on this plate, these are all the river snails right here, and then included over here, because I had space, are the 2 amphibious snails we'll talk about here in a second. If you're in any small stream, even maybe the size of the upper Scioto, even Olentangy, around here, Little Miami River system, you're going to encounter this species of snail. This is the liver alimnia. It is the common river snail that we have here in central Ohio and throughout most of Ohio in our smaller streams. It's going to be replaced in lower Scioto River and the Muskingum River and some of our larger rivers that flow out of the state of Ohio by the sharp horn snail right here. And then if you even go farther downstream into the Ohio River, then this is probably going to be replaced by these more stout, heavy-bodied pleurocerid snails. And in fact, 4 of these have only been reported from Hamilton County in Ohio. So those are some of our river snails. And then finally, and for this page right here anyway, the brown, or the Slender Walker. And the Slender Walker is an amphibious snail. It actually lives right at the edge of the water, on the top side of that edge, and then will go back down into the water, moisten its gills, come back up and feed on the mud that's right along the edge of a stream. And the same is true of this snail right here. Both of them are found at that edge and are amphibious. And then the last of the prosoprank snails are the mystery snails, which we see right here. and then the pointed campilomas, which we see down here, and then one other species. Mystery snails. So there's a story that's told that the reason these are called mystery snails is that you'll take one of these and you'll get it from a aquarium supply store, aquarium store. You'll have a single snail. It's doing its job. It's eating the algae off your glass. And then all of a sudden, the next day when you wake up, there will be hundreds of baby snails. And the mystery is, where did those snails come from? Because you didn't observe any eggs. You didn't see any on the rocks. You didn't see any in the glass. And snails lay eggs, but not the viviparids. The viviparids give birth to live young. And so that is the mystery solved. We had the native mystery snail and then two introduced species of mystery snail, the Japanese mystery snail, which is here, and then the Chinese mystery snail, which is here. And then the pointed campyloma, and then most of these guys right here will live buried just below the silt line, sand, and will travel in that environment for the most part. And there's even some data suggests that they might be deposit feeders rather than grazers. And then also in this plate are the two other non-native species, the faucet snail, and then our most recent introduction, which is the New Zealand mud snail. My first and only encounter really with the New Zealand mud snail was in 2004 when I was at Ohio State University Stone Laboratory teaching a class in field zoology. One of my students brought in yellow perch with a distended abdomen, and so we dissected it. And inside the stomach of that perch were thousands and thousands of these small New Zealand mud snails. The perch evidently liked to eat them. There were probably a lot of them around. And then the other group are the pulmonary snails. And so these are the lung-breathing snails, including this rather large family of swamp and marsh snails, also referred to as pond snails. And so this group includes the marsh pond snails, which are here, and then the swamp limnid, which is here, and also the mimic limnid, which is this shell right here. And notice the aperture of this shell and the aperture of this shell. This is what it's mimicking. The name of it is Pseudosuccinia, and this is a land snail in the family Succinia, Succioniidae. It's a very thin shelled species called an amber snail, and this one is mimicking that one for the most part. It's very thin shelled, sort of an amberish color to it. You'll find this in aquatic situations, mostly on vegetation, and you'll find this in terrestrial systems. And notice that the aperture is more limnid in shape than you see right here. This is much more elliptical in shape than this is more squared off. And so if you were to find this along the beach and you didn't have an animal or it wasn't in the water, then you should be able to distinguish this from this by the shape of this aperture. Two other families are the pouch snails, the phycelids. The most common one is this one right here, the tadpole, but the European is close behind. This is our newest species of snail for Ohio, first reported in 2019. It's the Phycella vernalis, the vernal phycid. And then rather odd snail, this one being a limpet. And so this is the creeping ancillid, but a flat limpet shaped shell rather than a coiled shell, as you see in the other snails. And then our final family of prosopranch snails are the planorbidés. These are flatly spired, and this one, the two-ridged ramshorn, is dextral. And it starts life just like all of these do, sinistral, but then it turns its shell over and starts building its shell as a dextral shell. And so as an adult, it has this sort of an appearance to it. When you see the rest of them in life, they are probably going to look like this. Because what these guys do, even though their shell is turning to the left, they'll turn their shell over and it will appear as if they're holding it like a dextral shell. And so the bellmouth ram's horn is pretty distinctive. And then the marsh ram's horn is quite a bit larger than this guy right here, but is also fairly distinctive. Then we have these smaller ram's horn snails, which again are pseudo dextral, but all of them will look to be dextral anyway. And so the gyros and the sprites. Those are the different species of land snail or aquatic snails that we have in Ohio. And so let's look at some of their anatomy, ecology, and some uses of aquatic snails. So anatomy-wise, this is a pulmonate snail. It has a lung. This lung would be in the same place as the gill. What happens during the early life of a gastropod is that the body changes its orientation by 180 degrees. And so what it does is it takes the intestines, which are right here, and then through the stomach, and then brings it back out, and then brings the anus back up near the front of the organism. Okay, that's pretty important because this is now opening up into the same area as the lung or the gill chamber, which would be located just in the same place, has the potential to foul its environment. This is particularly true if this animal is under some kind of predation force. And so this particular group has a head with eyes and a mouth and tentacles and things like that. If this is disturbed, the first thing it's going to do is take its head and put it in that rather large cavity. The last thing it's going to do then is bring the rest of its foot up and then close that cavity off. If it has happened to be a prosobranch snail, there would be an operculum right here, and it would use that operculum to close that particular area off. Okay. Snails have a well-developed head, a large muscular foot, and then this mass called the visceral mass. Snails don't like to be inside their shells, or because I mean they won't be able to feed and do other kinds of activities, but then they have the potential to foul their head as they would their environment. As far as ecology are concerned, snails are grazers. You can see how they would go about that. This structure right here is a radula. When just a series of teeth on here, when this radula is pushed out over this odontophore, these teeth are not erect, but when they bring it back in, they become erect. And so as they're moving back in, they throw this into their gut. And so that's the way a snail would eat as a grazer. We're not exactly sure how the viviparids use their radula differently to be deposit feeders, but there is some suggestion out there that they do that kind of activity. And so anyway, these snails will facilitate the transfer of energy to these molluscivore crayfish, fish, dragonflies, turtles, birds, a number of different species that eat freshwater snails, and for good reason. There are just so many of them out there. 700 species in North America alone. And then as far as uses are concerned, I'm going to talk a little bit about their uses as water quality indicators, historical malacology, and as habitat indicators. And as you may be aware by this point, I didn't really have a lot of pictures of freshwater snails. I have lots of land snails. I have lots of freshwater mussels, but every once in a while I would see something that would pique my interest, and this did. And I took a picture of this freshwater mussel shell with a limpet on the inside of it right here. You can see there's some discoloration here. There was some algae that was growing on this shell, and this animal was eating it. And what I discovered is that's not too unusual. There was a report by Robert Call in 1899 where he wrote a very peculiar group of small Linnaean mollusks, the ancillae, the limpets, will best be collected on the inner surface of dead unios or freshwater mussels. So they're pretty good indicators of habitat as well. Let's talk a little bit about snails as indicators of water quality. When I go to a place, when I go to a river, the first thing I look for are pleurocerid snails. If I can find pleurocerid snails, that usually says to me that water quality in that environment was good enough for those snails to survive, and it's probably good enough for these larger mollusks to survive. Now, I took this picture because of the larger mollusk that's sitting right here, this female Lampsels. But I noticed as I was looking through my photographs that these trails right here were all from pleurocerid snails. I'm sure I recognized the fact there were pleurocerid snails here first before I went and started looking at in earnest for these right here. And so you can see the same kind of thing right here in this nice, clear, clean water with good surfaces of rocks. All those dark spots on here are aquatic snails. So these both demonstrate some really fine habitat for snails. These do not. I've been doing some work on the Little Miami River system, mostly for these guys. And what I discovered is that, and what I do first, of course, is look for snails. And what I discovered is in Caesar Creek, which we have right here, lots of nice rocks for these snails to be on, but they're just so covered with vegetation that there's probably some nutrient enrichment right here that's going on. And this is too much of a good thing. There were no snails found in that environment. And then I went down into some other areas, mostly on the main stem, where there was a real sedimentation problem. And this rock right here, you can see all of the sediment, silt, and other fine particulate matter that's on this rock. The only snails I found on the top were pouch snails, phycelids, and I didn't find any pleuroceras at all. And that sends up a red flag for me. And so I started to look and I found none. I did look through my field journals from previous times that I'd been to the same places 30 years before and 15 years before, and there were abundant pleurocerid snails. I did pick up some rocks and look underneath, and there were snails underneath, the pleurocerid snails underneath. But sedimentation is a real problem here. Eliminating these snails from the tops of these rocks. Aquatic snails can be really good water quality indicators. And then a little bit about this stag moose that was found under 16 feet of soil in a calcareous shelly layer that looked like this. And the Ohio Historical Society sent this material to us at Otterbein, and we extracted, and they help with some of the extraction of these particular species of snails, including species that are lake species, and then some that are found in vegetation right at the margin of a lake, and then some that are found deeper in lakes, like these guys right here. And so we concluded that this skeleton was the result of a moose dying, probably in a marsh, but then slipping into deeper water where these species of snails and one species of fingernail clam would be more apparent. Okay, just a little bit of trivia. We're getting near the end of this. You can pick your favorite county in Ohio, and this is how many snails we have recorded for your particular county. The most is in Ottawa County right here, and then Franklin County, Delaware County, Pickaway County are pretty well represented too. But they don't include these 9 snails that are more or less distributed statewide. They're mostly big river or permanent kind of pond or swamp or marsh species. And if you don't have those permanent kinds of habitats, you're not going to find them here. These are the 9 counties in Ohio where we don't have any county specific records for snails, for aquatic snails. Okay. 5 of our aquatic snails are restricted to the Lake Erie drainage basin. 11 are restricted to the Ohio River system. 29 are found throughout both systems, and 5 are non-native species. As far as size is concerned, most freshwater snails are small. And so I encourage you to go out and look for them and be prepared to look for some small stuff. Pick up some boards, pick up some logs, pick up some rocks, and you'll find them on those kinds of environments. And so most of them are 10 millimeters or less. And within this group right here, there's their distribution. We have quite a number of them that are 3 millimeters and some that are up to 7. Okay. So, or excuse me, up to 6 millimeters. There are 7 that are 6 millimeters inside. So pretty small for the most part. But with little work, you can do it. And so what we're asking you to do, or what I'm asking you to do maybe, is to pick up a copy of this field guide on the freshwater snails of Ohio. And look at some of these entries like the mimic limniad right here, where we have scattered distributions of snails. And then maybe go into some of these counties and see if you can't find this particular species living on the vegetation in any of those permanent ponds. And then you can take a photo of it, a video, you can send it to me. Here's my email address. You also might want to get involved in the Freshwater Gastropods of North America project. A lot of information there too about the freshwater snails in Ohio and within the Ohio River system. And with that, I'd like to thank the Division of Wildlife for making freshwater snails more accessible, and to my friend Tom Waters for helping us to appreciate our aquatic snails and understanding them better. Now, Tom and I didn't have an opportunity to talk about what we would like to see next, but I think he would be okay with a slight modification to the logo of the Division of Wildlife. Thank you.